All right, so here are the solutions for the Paraprofessional Praxis Study Session Part A More Practice document. All right, so we've got 33 questions. I'm going to go kind of fast. My goal is to try to get through it in about 20 minutes. We'll go over the solutions, but again, at a quick rate. So if you need to pause the video to kind of take a look at what's happening or go back and rewatch it, feel free, because I'm just going to go fast and go over the solutions for these 33 questions. Here's my email, phillea@nv.ccsd.net. If you have any questions, give me an email and we can talk about any of these problems in greater detail. Okay, number one, Veronica played 24 games and scored 6 goals. At this rate, how many goals will she score in 60 games? So if we make a table, games and goals. All right, games and goals. All right, so we've got 24 games, 6 goals. I'm going to scale this down. I'll divide this by 2 to make it 12. I'll divide this by 2 to make it 3. So we cut the games and goals in half. We want to get up to 60 games. All right, so turns out I could keep counting by 12s if I want, but I know that if I do 12 times 5, that's 60 games. So that means I need to do 3 times 5 to find out that that is 15 goals. The answer is 15 goals for question number 1. All right, question number 2. Jelena had an account balance of $214.50. Then she used her debit card to make 2 purchases, one for $190 and one for $110.75. What's the new account balance? All right. Number 2, talking about a number line, so she starts above 0 at $214.50. But she used her debit card twice, so it's going to decrease and decrease again. In fact, let's see how much it totals in the purchases that she made. $190 and $110.75. So that's a total of $300.75 of purchases on the debit card. Notice she doesn't have that much money, so it's going to end up below 0. So how far below 0 will end up? Well, let's figure out the difference between these two numbers, and that will tell us how far below 0 her account is going to end up. So subtracting them to find their difference. And it looks like she's going to end up at negative $86.25. All right, there's number 2. Okay, number 3. Which of the following numbers are less than 45%? All right, sorry, my screen blacked out for a second. We're back on it. Okay, so 45%. 45% is almost 50%, a little bit less. So we've got 1/4, which is a benchmark fraction that we just kind of know is 25%. So that one is less than 45%. So that's one of the ones we want. We've got 5/8. So 5 out of 8 is more than half, because 4 out of 8 is half. This is more than half. We're looking for less than half, so it can't be 5/8. We've got 6/12, which is exactly 1/2. This is almost half, but less than half. This is too big, so it's not 6/12. Then we've got 3/10. And remember, every fraction is a division problem. You could do 3 divided by 10. 10 does not go into 3, so if you had a decimal and a 0, you'll find out that it's 0.3, which if we move the decimal 2 times, is 30%, which is less than 45%. So the 2 that we want to select are the 1/4 and the 3/10. Those are both less than 45%. All right, that was number 3. On to question number 4. What is 0.8 but written as a percent? So converting fractions and decimals and percents, just like we did in the last problem, you can move the decimal 2 times. You have to put a 0 in this blank spot. So 0.8 is the same as 80%. And there's your answer for that one. All right, question number 5. Bus A arrives every 12 minutes and bus B arrives every 18 minutes. If they both arrive at 1:36, what's the next time they're both going to arrive at the same time again? So let's make a list of the times for A and B and see when they arrive at the same time again. This is question number 5. All right, so they both arrived at 1:36. This one is every 12 minutes, so we're just going to keep on adding 12 minutes. So now it's going to be 1:48. Add 12 minutes again. That's going to take us to exactly 2 o'clock. Add 12 minutes again. That will take us to 2:12. And we can keep doing this as far as we need to, but let's check out this bus. This time, this bus leaves every 18 minutes. So 18 minutes after 1:36. So you have to add 18 minutes, and that's going to be 1:54. Now, if you add 18 minutes again, that's going to take us after 2 o'clock. Let's see here. It's going to take us to 2:12. And check this out. They both arrive at 2:12. So the next time they both arrive at the same time, 2:12 is the answer. Okay, that's going to bring us to question number 6. A rectangular photo has an area of 5/12 square feet. We know the length of the photo is 5/8 of a foot. So what is the width? We talked about using guess and check for a problem like this. All right, so the area is 5/12, and we know the length is 5/8. The width is what we don't know. So remember, area in a rectangle is equal to length times width. So we need to guess what number can we multiply by the length, and it will equal this answer over here. So if we select A, it says 1/2. All right, so to see if 1/2 is the right answer, we'll do 5/8 times 1/2. That equals 5/16. We're looking for 5/12. That wasn't the right answer. So let's guess a different number other than 1/2. So there's 3/4. So if we multiply, we get 15/32. And not 5/12. Okay, so let's guess another answer. The next one is 1/4. Now when we multiply, we get 5/32. We're looking for 5/12. Still not the right answer. Let's hope this last guess is the right guess. The last answer is 2/3. So we'll multiply and we'll get 10/24. And check this out. You could simplify 10/24. 2 is divisible into 10. That equals 5. 24 divided by 2 is 12. So this is equal to 5/12. That shows us that 2/3 was the right guess for the width. 2/3 is the answer. Okay, that's question number 6. Question number 7. A deck of cards has 52 cards, 13 clubs, 13 spades, 13 hearts, and 13 diamonds. What's the probability of randomly selecting a card and having it be a diamond? So here there's some extra information. Here's what we really know. Let's say this rectangle represents all the deck of cards. What we know is that there's different types of cards. Some of them are diamonds, some of them are hearts, some of them are spades, some of them are clubs. And what's important is there's the exact same amount of diamonds, hearts, spades, and clubs. So really it's just that there's 4 different types of cards and they're exactly equally likely to be picked. So what's the probability of getting a, diamond? Probability of getting a diamond is that's 1 type of card out of 4 types of cards. 1/4 is the answer. So there's extra information in this problem, but really we just have to understand that there's 4 types of cards, all equally likely to be chosen. 1/4 probability of a diamond. That was number 7. Number 8. Okay, order these shapes from least sides to most sides. So we have to understand these prefixes for number 8. See, one of them is a hexagon. So a hexagon has 6 sides. I remember the word 6 has an X and hexagon has an X. Hexagon, 6 sides. Then there's a quadrilateral. Quadrilateral, 4 sides. Quad means 4. Okay, there's a pentagon. Okay, penta tells us it's 5 sides. Pentagon, 5 sides. And octagon. And let's see here. An octagon has 8 sides. Octo is 8. All right, so if we're going to go in order from least to most sides, we're going to start with the quadrilateral. Quadrilateral first. Next, we're going to go to the pentagon. Next, we'll go to the hexagon. And the most is the octagon. So quadrilateral, then pentagon, then hexagon, then octagon. It's knowing the prefixes to know how many sides are in the shape. That was question number 8. Moving on to question number 9. Okay, we've got a parallelogram MNOP. We know the perimeter is 48. We know segment OP is 8, and we have to find PM. Okay, so let me sketch a parallelogram. All right, so there's a quick sketch of a parallelogram. Let's call this M, N, O, P. Now, you have to put those in order as you go around. Then if it's called MNOP, then you have to put the names of the vertices going MNOP. All right, so we know the perimeter is 48. We know that you add up all the sides to get the perimeter. OP is 8. So from O to P right there, that's 8. Now, if that's 8, that means this is 8. The question is, what is PM? So here's the question. Whatever that is, this is the same thing. So we have to add up all of these to get 48. Let's use guess and check. So one of the guesses is, I'm going to guess 12. 40 doesn't make sense. 40 is way too big. But I'm going to guess maybe 12. Now, to see if I'm right, I have to add 12 plus 8 plus 12 plus 8. And if I do that, that equals 40. So that's a little too small. I'm trying to get 48. So something a little bit bigger than 12. And let's see here. All right, so the next biggest one is 24. I wonder if I made a mistake on this question, because that's going to be way too big. So let's see here. And what about if we tried 16? Yeah, if we tried 16, that would work out. So 16 plus 8 plus 16 plus 8, that does equal 48. There we go. So the right answer is 16. And it's funny because I'm looking at the problem that I created, and 16 is not even one of the choices. So I'm going to have to go and amend this so that when you guys look at it, the 16 is one of the choices, because 16 is the right answer. So I'm making a note over here for myself that I need to amend question number 9 because I made a mistake the first time I wrote it out. All right, but we're still rolling along here. We're going on to question number 10. Question number 10. A die is rolled twice. What's the probability that it will land on the same number both rolls? So we talked about making an organized list of all the things that could happen. So it could be a 1-1, could be a 1-2, could be a 1-3, could be a 1-4, could be a 1-5, could be a 1-6. And this is going to take a minute, but I'm going to write down all of the possible outcomes for rolling 2 die, just like we had done before. How many different outcomes do you think there are going to be at the end? All right, got all the outcomes. If you count them all up, there's 36 outcomes. How many out of the 36 outcomes that we created are the same number being rolled both times? So if you rolled like a 1 and then a 1, that counts. But none of these other ones here count. But a 2 and then a 2, that's the same number both times. Same thing with a 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. If you count them up, there are 6 outcomes that make that true. So the answer is 6 out of 36, 6 over 36. If you look at the answers, none of them say 6 over 36. But if you simplify this, divide the numerator and denominator both by 6, and it's actually equal to 1/6. And 1/6 is the answer. There's a 1/6 probability of rolling a die twice, having it be the same number both times. That's going to bring us to question number 11. Sketch a bar graph showing the following inches of rain. All right. Number 11, bar graph. We're going to set it up like this. Okay, so on Monday, it was 2 inches of rain. So the lowest is 0, the highest is 2.5. So this is 0, we'll do 1, 2, 3, little lines in there for the 0.5. Okay, so on Monday, it was 2 inches, like that. On Tuesday, it is 2.5 inches, so we'll go between 2 and 3. And on Wednesday, it was 0.5 inches. That's 1/2 of an inch. So 0.5 halfway between 0 and 1. And finally on Thursday, not finally, but there is Thursday. Thursday was 0 inches, so just right there at 0. And Friday was 1.5 inches. Okay, then it wants us inches of rain. We'll give it a title. It wants us to get the median value. So to get the median, remember you put the data in order from least to greatest, starting with 0. The next number is 0.5. Then we've got 1.5. Next 2. Finally 2.5. And the median is the middle number. In this case, there is only one number in the middle. 2 numbers are below it. 2 numbers are above it. 1.5 is our median number. There we go. All right, that's going to bring us to question 12. We've got 18 minus 12 divided by 3 times 4 plus 9. Remember, the skill we want to do here is bringing down our work. So write down the original problem. Remember, this dot in between the 3 and the 4 means to multiply. And in the order of operations, remember PEMDAS. Parentheses first, there are none. Exponents next, there are none. Multiply and divide from left to right. So skip the subtraction for right now. We're going to have to do the divide, and then after that we're going to have to multiply. And then the add and subtract will be last. So let's divide first. And I forgot to write 12 instead. There we go. 12 divided by 3 is 4. So it's 18 minus 4 times 4 plus 9. So again, I solved 12 divided by 3. That's how I got the 4. Now we're going to multiply. 4 times 4 is 16. So bringing everything down. 18 minus 16 plus 9. Now add and subtract, go left to right. So we're going to do this first. That gives us 2. Then we'll add the 9, and that's 11, and 11 is our final answer for that one. All right, that was question number 12, order of operations. Question 13, which of the following are prime numbers? Okay, we're looking for prime numbers here. And the options are 15, 23, 51, 52, 61, 87, 90, and 105. So remember, there's divisibility rules. Like, I know that this number is divisible by 5 because it ends in a 5, which means it's got more than 2 factors. It's got 1 and 15 and 5 and also 3. So that's not a prime. All right, so this one is divisible by 1 and 23, but is there anything else? So if you think about, is it even? No. Is it divisible by 5 like this one? No. And so that, I believe, is going to be prime. Now 51, what do you think? I know that we could do 1 times 51, but is there anything else? Now check this out. Remember the rule where 5 plus 1 is 6? 3 is divisible into 6? That means 3 multiplied by another number is equal to 51. If we found out the other number, it's actually 17. But the fact that 3 divides into 51 means it's not prime. This is even, which means it's not prime. It's divisible by 2. 61, I believe, is prime. 87, 8 plus 7 is 15. And 3 is divisible into 15, which means 3 is divisible into 87, which means it's not prime. This ends in a 0, meaning it's divisible by 10, which means it's not prime. This ends in a 5, which means it's divisible by 5, which means it's not prime. So again, we had to remember those rules for 2, 3, 5, and 10 to kind of know which ones were prime or not prime. But 23 is prime, so is 61. Okay, that was question 13. Moving on to question 14. There are 6 members of the Ramirez family. Each of them bought 5 tickets for the charity raffle. And there are 6,000 total tickets. So what's the probability that somebody in the Ramirez family is going to win this grand prize? So for question 14, we got 6 members of the family. Each of them bought 5 tickets. That means they have a total of 30 tickets that they bought. So they have 30 chances to win this raffle, but 30 out of how many? 30 out of 6,000 total tickets. All right, but we're going to need to simplify this fraction. I noticed right away I could divide by 10 because they both end in a 0. So that's going to be 3 out of 600. But I know that I could divide these both by 3, That's going to equal 1 out of 200. So the final answer is the Ramirez family has a 1 out of 200 chance at winning the raffle. Okay, going on to question 15. All right, in a survey of 150 patrons at the local restaurant, they each picked their favorite menu item. Okay, question 15. So for lasagna, it was 3 out of 10 people that picked that. And for tri-tip, it was 24 out of 75 that picked that. For nachos, it was 12 out of 50. And for Caesar salad, it was 21 out of 150. All right, but we want to know how many people out of 150 total votes were there. So let's change this 10 into 150. We'll do that by multiplying it by 15. That means we multiply the numerator by 15, and now we know that lasagna got 45 votes. Again, we want to make this 75 into 150. If you do 75 times 2, it's 150. Multiply the numerator by 2, and that is going to be 48. That's 48 votes for tri-tip. All right, we want to make this denominator into 150. You have to multiply that by 3 to do that. Multiply the numerator by 3, 36 out of 150. Nachos received 36 votes. And the Caesar salad already is out of 150, so that's 21 votes. And so the question is, list the menu items in order from least popular to most popular. So the least popular was the Caesar salad with only 21 votes. So Caesar salad goes first. Next is going to be nachos with 36 votes. That's surprising because nachos are amazing, but it looks like what was the L? That was the lasagna. So lasagna is amazing too. Lasagna got 45 votes, and the most popular menu item with 48 votes is the tri-tip. And so there's the order from least to greatest, or least popular to most popular, by making common fractions with a common denominator. So equivalent fractions with a common denominator out of 150. Okay, that was question 15. We're on to question 16. And man, I'm not doing so great time-wise. Question 16. All right, an input-output table with these values. So the input is the x, the output is the y. So we got an xy table. So we've got 0.11. We've got 0.35. We've got 0.59. We've got 0.815. The question is, which of these equations has the right rule? So let's use guess and check. One of them says y equals x plus 4. So to see if this is the right rule, let's take out the x and we'll put in the x number. Does this plus this give us the y? Well, 1 plus 4 doesn't give us 1, so that's not the right rule. All right? One of them says y equals 2x minus 1. Now remember, 2x means 2 times x. So let's take out the x, and in its place put in the x number. So if you did 2 times 1 minus 1, would that equal 1? And actually it does. But it can't just work one time, it's got to work all the time. So now let's try the 3. So if we take out the x, and in its place put in a 3, this should equal 5. Does 2 times 3 minus 1 equal 5? Yes, it does. So now we'll take out the 3, we'll put in a 5. And if this equals 9, and it does, then we're on the right track. And lastly, you could try putting an 8 in there and seeing if this equals 15, and it does, because this one is the right rule, 2 times x minus 1. All right, so looking at the time, we'll do a part A and a part B video for these questions. Let's do one more question. We'll put the rest of the questions on part B. Okay, so 17 will be the last one that we answer in this part A video, and then we'll make a part B video and answer the rest. 27, again, is the order of operations. Not 27, 17, I should say. 27, order of operations. The problem is 24 divided by 6 plus the quantity of 5 times 3 times 11 plus 19. All right, so PEMDAS. Helps us to remember the order of operations. Parentheses first. There's parentheses. We got to do that. That equals 15. Bring your work down. 24 divided by 6 plus 15 times by 11 plus 19. Okay, I did the parentheses. Are there any exponents? No. Now let's do the multiplying and dividing from left to right. So we're going to take care of this. That's dividing. We'll save that for later. We'll do this because that's multiplying. We'll save that for later. So 24 divided by 6 is 4. Plus, we have to do 15 times 11. That's 165. And then plus 19. And let's see here. So now we've got only adding and subtracting. It's all adding actually. So adding from left to right. Add those up. That's going to be 169. Add 19 to that. That's going to be 180. Is that 80 or 190? 60, 70? Wait, it's neither of those. Let me add the correct way here. All right, so we got 188. There's what we're looking at. All right, 188 for question 17. Okay, so that's going to conclude part A of the solutions for the ParaPro Praxis extra problems. And I'll do the rest of the solutions in part B, so check those out. Remember, email me with any questions.